Hi, I'm Nick, and if you're watching this, that means you're my classmate in Duke University's Machine Learning Foundations for Product Managers class. Today, I'm sharing my end-of-course project where I used machine learning to create an optimized model that allows us to predict power plant energy output based on environmental conditions. To do this, I decided to use Python and the scikit-learn toolbox. Ready? Let's go. For this project, we're working with 4 key environmental readings: ambient temperature, exhaust vacuum, ambient pressure, and relative humidity. The target variable is energy output, PE. Our goal is a predictive model that's accurate, interpretable, and efficient. I started by visualizing relationships in the dataset. Here are the first few observations. A heat map shows all features are correlated with PE, with AT and V having the strongest correlations. And a scatter matrix confirms that AT and V are the most predictive factors. Since the target is numerical, I started with linear regression for simplicity. Since some of the features seem to have significantly more influence on the target than others, I decided to do feature selection with lasso regression so that any irrelevant features could be eliminated. I split the data 80-20 into a training set and a test set, and then I used the lasso CV function to train the model. Lasso CV also performed cross-validation and found the optimal alpha, which controls the strength of regularization. To evaluate model performance, I decided to use mean squared error, since I would imagine that a power plant would prefer frequent but small prediction errors to huge ones that happen sporadically. This trained model has a mean squared error of 20.3 and an R-squared score of 0.93. Pretty great. The root mean squared error is 4.5. That means that on average, this model's predictions differ from the actual power output by about 4.5 megawatts. Since the PE values range between 400 and 500 megawatts, this error is pretty impressively small. But why not try to do even better? Because there could be some nonlinear relationships my first model didn't account for, I decided to create a random forest model. I used grid search CV to optimize the parameters like max depth and minimum samples split. The trained model had an R-squared of 0.96, which was higher than the lasso model, and a mean squared error of 10.4, also an improvement. The root mean square error was 3.2, so between the two models, my random forest model is the winner. But it's also more complex. In fact, training took over a minute compared to about a second for the linear regression model. At this point, I remembered how ambient pressure and relative humidity appeared to be less impressively correlated with the target than the other two features. Could we eliminate them in the random forest model to simplify it without tanking performance? I went back and removed them and retrained using only AT and V. I found that the streamlined model had a slightly higher mean squared error of 13.8, and the R-squared declined just slightly from 0.964 to 0.953. Here's how the 3 models stack up against each other. The first lasso model has the lowest accuracy. However, since it's a linear model, it has high efficiency and interpretability. The 4-feature random forest model has the highest accuracy, but the lowest efficiency, meaning it would take longer to retrain and more computational resources to run once implemented. The 2-feature simplified random forest model has medium accuracy relative to the other two. It's more efficient than the 4-featured random forest model, but also less efficient compared to the lasso model. It exhibits medium interpretability since it only uses 2 features. However, it's also nonlinear, which makes it harder to explain to stakeholders. So who's the winner here? Both the linear regression lasso model and the random forest model excelled in different ways, but the simplified random forest model was solid in all 3 categories. So without having more context around how the output would map to the outcome metric for this particular power plant client, I'd choose the simplified random forest model as the winner here. Before I go, I'd like to thank you for taking this time out of your day to review my project. Best of luck with all of your future machine learning adventures. See you later.